Let's go to page 131. This is lesson 3-6. The objective of this lesson is to use systems of equations to solve problems. So let's go over example 1. It says to use a certain computer database, the charge is $30 per hour during daytime. So what you want to do is go and write down all the information. Okay, so this is daytime. And $10.50 per hour for the nighttime. If a research company pays, so the total is $411 for 28 hours of use. And it asks to find the number of hours charged at the daytime rate and at the nighttime rate. So what first you need to do is set up your variable to answer the question. So the question asks the number of hours. So you want to let, and you want to choose a variable that kind of go along with that. So let D equal to number of the daytime hours, okay, that it used. And let N equal to number of the nighttime hours. Okay. And so now you can go and write the equation. So there are total 28 hours. So D plus N equal to 28 hours. Okay, so the daytime hours they use and the nighttime hours use total 28 hours. Then you have to write, so that's this one here. Then you have to write the equation based on total number of money. Okay, so $30 per hour times number of daytime hours. So this would be for daytime charge. Plus $10.50 per hour times the number of nighttime hours, and this will equal to total cost of $411. So once you translate into equations, after that all you have to do is just go and solve equations. So this equation, these two equations look similar, so you want to use the elimination method, and it's better to go and eliminate the lower number. So I'm going to multiply by negative 10.5, so that N would be opposite. So I end up with negative 10.5 D minus 10.5 N equal to, and then you can use your calculator to multiply out. So you got 28 times 10.5 negative equal negative 294. Okay, then after that, I'm going to put this equation down here. So minus 10.5 D minus 10.5 N equal to negative 294. So when you subtract, you're going to get 19.5 D. This cancel out, and this will equal to 117. Okay. Then after that, divide by 19.5. Divide by 19.5. So daytime hours that it used would be 6 hours. Okay. And once you find daytime hours is 6 hours, then you can figure out the N using any one of the equations. So this would be the easiest one to use. So D plus N equal to 28. And then you're going to substitute this into here. Then you minus 6 on each side. So N equal to 22 hours. Okay. And that's it for example 1. Okay, let's go to example 2. So first read the problem. It says to measure the speed of the jet stream, a high-speed, high-altitude west to east wind, a weather service plane flew 1,800 kilometers. So again, sometimes you might want to draw the picture. Okay, so the distance equal to 1,800 kilometers. As a tailwind, so you got tailwind, so you have the wind going this way. So airplane is flying, and it's flying with the wind. Okay. And so this is the eastbound, and the time took 2 hours. and the westbound, so to coming back. Now when you're coming back, the wind is still going this way. Okay, so this is the airplane coming back. The time, the distance doesn't change. So distance is still 1,800 kilometers. And the time is 3 hours and 20 minutes. Okay. You want to find the speed of the jet. So you're looking for the speed of the jet. So you're looking for the speed of the jet and speed of the jet stream. So jet stream, sorry. So this is the speed of the plane and speed of the jet stream. Okay, so the wind, we're just going to call it J for the jet stream. Okay, so again, you can use W for wind, or you can use J for jet stream. So either way, so that's going to do that. Okay, and this is the west direction. Now, when you have this kind of situation, this is the motion problem. So sometimes it's better to go and make the table to keep things organized. Okay. So this is going east and this is going west, and this is a formula. So it's r times time equal to distance. Okay. So the formula for the travel is r times time equal to distance. This is the rate. This is the speed times time equal to distance. Okay. So let's go and put everything in here. So when you're going east, the rate is going to be the airplane plus the jet stream, right? Because it's going same direction. Okay, it doesn't tell you to use that. The time is 2 hours, and the distance is 1,800. Now coming back the west, now you got a headwind, so it's hard to use the speed of airplane minus the jet stream, because jet stream is going to push it back. And this would be 3 1/3. Okay, because 20 minutes is 1/3 of an hour, so that's that. And again, the distance would be 1,800. Okay. Okay. So now you can write down your formula now. So you got P plus J times 2 equal to 1,800. That's for east. Coming back, you got P minus J times, I'm going to make this into 10 over 3, right, make it into improper fraction, equal to 1,800. So now you have to solve two equations. Now before you solve, let's go and simplify this a little bit. So divide by 2 on both sides. So you got P plus J equal to 900. For this one, I'm going to multiply by 3 over 10. So multiply by 3 over 10, so that this will cancel out. So I get P minus J equal to 540. So now the J is already opposite, so it's kind of nice. So I'm going to put this under here. So when you add, you get 2P equal to 1440. Divide by 2, divide by 2. So the speed of the airplane would be 720 kilometers per hour. Okay. And once you do that, you can come over here to look for the speed of the jet stream. So substitute, so you got 720 plus J equal to 900. So minus 720. So J equal to 180 kilometers per hour.